any homework assignment questions that you wanted to take a look at before we get going? Yeah?
I just wanted to know if some students who didn't make like a table or anything like that.
For the homework or
The
for
homework.
um
The assignment, because I didn't use like that or anything like that. I know that was like what we were supposed to use a data set. But
Oh, you mean like when it tells you to use StatCrunch, but then you didn't use StatCrunch?
and then he sent us an email like,
Yeah.
to show as many data sets as possible. But I didn't use that.
That's okay. That's okay. Yeah. Yeah. If StatCrunch is there as a tool, you don't have to use it. There's going to be some stuff later down the road that if you know how to use StatCrunch, you'll be happy because it'll make your homework go about 10 times faster.
Yeah.
But yeah, you don't have
So it
to.
wasn't like.
Required. No. Any other questions? No? Okay. So, what I wanted to do is I wanted to get some ideas about how you guys tried to figure out what percent of trucks there were in the Tri-Cities. I'll show you how I did it because I actually tried this myself. I did it the lazy way, but we'll see. I think it still worked okay. So for those of you who have already sent them in, hopefully you brought some with you. I want to know some of the methods that you guys use because I've seen a few. I haven't read through all of them yet though. So what were some of the methods you guys use? So we're talking about estimating the percent of trucks in the Tri-Cities. All right. So, what kind of ideas did y'all have? How'd you do it? Anybody want to start? Go ahead. Just throw it out there.
I sat at a coffee shop where I counted 150 vehicles.
Okay. So, what coffee shop did you sit at?
Roasters, like $3.95.
Okay. So Roasters. And did you just look at you watched the cars going by on what road?
3.95.
Okay. So you counted the cars on 395?
Yeah.
Okay. Where's Roasters on 395?
Hills Brown.
Okay, that means nothing to me. Sorry, I should have been.
395.
Yeah, it's on 395. Yeah, is that somewhere? I know where the. Oh, it's like out further. Okay, cool. Like out by Southbridge-ish. Okay, so in that area. So you can tell I don't spend that much time at Kent Lake. Sorry. What else?
I chose like 3 popular areas that I thought in each city when I visited them.
Okay, so you did one in every city.
Yeah, and then I googled like when their peak times were.
Okay, where'd you go?
So in Pasco, I did the Walmart on Road 68, which is by my house.
All right.
And I did that at noon.
Okay.
And then in Kennewick, I did the mall
Okay, so you hit the mall in Kennewick
at 2.
at 2 o'clock in the afternoon.
Yeah. And
On
then
what day?
Saturday.
Okay, were these all on Saturday?
Yeah.
Okay, cool. So all Saturday.
And Richland, I did the Howard Amen Park in the morning.
Okay.
At 8 in the morning.
All right. Also on a
Which
Saturday.
wasn't really their peak time, but it was just when I was in Richland.
Okay. Howard Ammon and Richland in the morning.
Yeah.
Okay. Nice. So you made sure to get every city.
Yeah, and then I just counted like my neighborhood as I drove by.
And then just random. Okay.
Yeah.
Just in your own neighborhood. All right.
I figured anything counts, right?
What's that?
I figured anything counts.
That's true. Yeah. What else? So so you got every city. All right. What else? Anybody do it a different way? Yeah.
I just did counted the houses in my neighborhood and how many trucks in the neighborhood, so the amount of trucks per house, and then that was on a Sunday evening when,
So you just like looked in their driveways.
yeah, so, no, I did, and
Yeah.
so then for every like 42 homes, there's 17 trucks,
Okay.
and then I found like the number of households in the Tri-Cities. They
Oh,
have
okay.
a census online.
Okay.
So then for every,
Okay. So you were looking for number, like physical number.
well, yeah, but so
Mhm.
like 40%, so 17 trucks per every 42 households.
Oh, okay.
So then that's like 40%.
Okay.
So then
All right. So you think trucks per household? Yeah, that's not a bad way. Did you like look in people's garage windows and stuff to make sure you got them all?
I like that percentage of truck. If their truck wasn't there, I'm like, I know they got a truck because it's not. It's like 42 homes. It's not that.
Okay.
So.
So you have someone on 395. You have someone going to busy places in each city, walking around your neighborhood. How else did you do it? Anybody else do it a different way? How did you do it?
I just went to parking lots because
Parking lots are easy.
parking lots drive on roads. And I took a sample of 100 cars and tallied how many.
Okay, what parking lots did you go to?
I went to the Richland Walmart and the Costco parking lot.
So Richland, Walmart. Which one did you go to?
Costco.
Costco. Good thing we weren't counting Suburbans. And then the mall parking lot. Okay. Nice. All right. What else? Oh, Costco, Walmart. I was thinking Walmart. I got some. Don't worry about that. It's the Costco, Walmart. Okay. What else? Anybody else do it differently? No? No other creative ideas? You sure? How many of you guys? Yeah, go ahead.
I actually had a partner help me because she counted all the cars and I counted the trucks.
Okay.
And we just parked like by the soccer field, right near CBC.
CBC's.
The freeway.
Oh, okay. So you parked and you counted the freeway. So
Kind of hard, but it worked. And we did it for 30 minutes, and then we just tallied at the end.
so that's what 182.
Yeah.
Okay.
We did the trucks and she did the cars.
So she just counted vehicles in general, or
Yeah.
something, and then you
Well,
counted
she
trucks.
didn't, like, include like if there was like a motorcycle, she
Yeah.
just counted cars.
Yeah.
And then I did trucks.
Okay. All right. So you did the I-182. So you did the freeway. Anybody else do freeways at all? Anybody else count freeways? So some people did freeways. Did any? How many guys did? So how many guys have parking lots? How many counted parking lots? Okay. So how did you choose? Did you just do one parking lot, or did you choose multiple parking lots? What parking lot did you pick?
Walmart, because everyone goes to Walmart.
The Walmart parking lot? Everyone goes there. No one wants to be there. What's going on? So what else? Right. What? How did y'all pick your parking lots? You said you did a parking lot. You did the mall?
Yeah, 'cause I
Okay.
worked there.
Yeah. Where'd you go? You did the Walmart? Yeah, you did all three Walmarts. So was very nice. So that's a little bit of driving. Okay. So how many cars did you count?
A lot. 50 from each.
Oh, you did so you did 50. How did you pick your 50 cars?
Just wherever I parked and I went.
So wherever you parked, and then you just picked 50. Okay.
You reimburse us for gas.
Huh? I'll give you the travel reimbursement form, and you can take it up with CBC. Good luck. They're a little stingy.
I had to drive up here from Prosser, so
So from Prosser?
did, 20 bucks.
Oh, okay. I guess you could have done Prosser. You could have done Prosser, but that's pretty good. Did you do parking lots or streets?
I did streets.
Okay.
I did kind of the combination of having, because I had a partner with me as well,
Mhm.
and then I did the 3 areas. Like, 'cause I took a sample of 600 cars all together.
Nice. 600.
Did 200 cars in each area.
Nice. Did you just go on the streets though?
Yeah, I did Clearwater, Route
Okay.
68, and George Washington Way.
Okay. Nice. Pretty representative, probably. Okay. Anybody else do it differently? Yeah.
Yeah, well, I work at Macy's and Mall,
Okay.
and I just asked the customers as I was ringing them up what they drove in here.
Yeah.
The cars of just the roads they could get.
Oh, okay.
I
So you,
just tallied trucks and cars.
Oh.
They kind of did the work for me.
there you go. So you sample customers? Yeah. Did you ask them like what color it was, license plate number, social security, mother's maiden name? That's cool. Yeah, right? So then you don't actually have to count cars. Yeah, so you got the people.
Yeah, because I mean, I figured they drove
And that was at Macy's?
something, yeah, Macy's.
Okay. Let's come through. Anybody else do something creative? No? Any other ways?
I asked my aunt while she was at the DMV if she could ask the person
Uh-huh.
like how many trucks are registered, and I guess like the girl looked at her crazy, and that was the end of it. She's like, no, I don't have access to that.
She was like, you don't pay me enough.
Yeah.
Right. Okay. So, So then let's think about these ideas. So, and let's go through and see why they are good ideas or bad ideas. So for the roasters on 395, what's good about that choice as choosing cars there?
395 is a major road.
Yeah. So it's a major roadway. It's a roadway lots of people travel, right? Okay. What are some downsides of maybe picking only 395 as your sample?
You're only in one city.
You're only one city. Okay. So that could be a problem. What else?
There's probably a lot of big like semi trucks and stuff.
Yeah. Okay. So what is a truck? How did you define a truck?
Just like a van.
I did
So-
like
Yeah.
Does it go ahead?
My husband says that semis are not owned. You don't own.
Okay. So I didn't count commercial trucks like semi trucks. So what about a dump truck?
A what?
What about like a dump truck? Is that a truck? What about like a service vehicle, like a service truck, like that works for the cable company or something? You would count that as a truck if it drove by? Okay. All right. So we all did anybody include semis in their truck counts though?
No.
Nobody includes semi trucks in their counts? Okay, so we all agree semis are out. Okay. All right. So what else about 395? Good things, bad things?
It's a big thing.
Okay.
There's like a big variety of cars.
Yeah. What could be a problem about it though? Anybody? Yeah.
They might not be from the Tri-Cities.
So that's one thing to think about with some of these strategies. It's something I thought about too, and I ignored it because I don't want to deal with that. But it could be a problem because 395 is a big like a thoroughfare, right? A lot of people traveling that road aren't actually from this area. Lots of them aren't even from the state necessarily, right? So 395 connects down to Hermiston and I-182 that goes the other way. So yeah, that could be a problem. We were probably counting people that don't actually live here. True, but that's okay.
I mean, your question was just like on the road in Tri-Cities. It didn't state like. Do you think
Okay,
people live there?
sure.
Like,
Yeah.
Do you think the trucks on the road people live there? But it's like.
Yeah.
It was a car it was a vehicle on the road at the time. So.
Yeah. I'll buy that. That's okay with me. Yeah. I think 395 is a pretty good choice. What about this one where you go 3 areas? You got Walmart, the mall, and Howard Ammon. How you guys feel about that idea? Feel pretty good about that one?
good broad spectrum.
It is pretty broad spectrum. What are you thinking could be some downfalls to that strategy though? It's a lot of work. Okay? So if your constraint is time and money, this could be a problem, okay?
I got other stuff to do.
You got other things to do. What else could you possibly have to do besides statistics? Okay. You could do statistics at a hockey game. Yeah, work. Yeah, dang. Bills still come even when you're in school, huh? Okay, so any downfalls to this besides it's hard? What are you thinking?
I couldn't use my gas.
Okay, yeah. Time consuming, money consuming. What else? Could you think of any problems with this strategy?
So I chose a starting point and I did an end point. I didn't go back, so I could have possibly missed cars that came in
Right.
the
Okay.
parking lot.
But you did parking lots basically.
What?
You did parking lots?
Yeah.
Yeah, it wasn't like people passing by.
Yeah.
Yeah. Okay. So,
Chance you could double count cars.
yeah, you could make some errors. Yeah, that way. I'm trying to think. Do you think it's more or less likely that people that are parked at these locations are trucks compared to the rest of Tri-Cities?
I would say probably less likely,
Maybe.
because I think if I had a truck and a car and I was gonna go shopping, I'm not gonna waste all my gas in the truck.
Yeah.
Close shopping at the mall.
Yeah. Well, and I think too, maybe the Walmart and the mall as representatives of Pasco and Kennewick, but I don't know. Do you think Howard Ammon in the morning is very representative of Richland? In terms of registered vehicles or vehicles on the road? It could be. I think that one might be a little heavily weighted towards sedans and vans, maybe, versus trucks, but who knows? Yeah, whatever. I think it's pretty good.
Yeah. Or some trucks they're hauling boats,
That's true. Yeah. Okay, what about just going around your neighborhood and counting up people in your neighborhood?
That's really only representative of your neighborhood.
Mm-hmm.
You're locked into one.
So, yeah, it's specific. So depending on where you live, what kind of neighborhood you live in, right? If you live in the city or if you live maybe in a more rural neighborhood or something, okay, it'll change your results. Let's see. Parking lots seem to be popular. this person here with these parking lots, what did we miss? I think we missed Pasco.
Yeah.
But, you know, the mall's pretty representative probably in a way of the 3 cities because it's probably frequented by people from all cities. But I don't know about trucks.
I would say Costco is.
Costco too. Yeah, probably pretty representative from the 3 cities. Okay. I-182 is, what do you think about that one?
That's a good one.
Another thing like
I feel like same as
395, I mean, it's a good one.
Yeah.
for
A lot of-
counting, But it's, you're gonna get people who aren't from here, who are
Yeah.
driving through.
A lot of through traffic. Yeah, that's true. So probably depends on what time you go out there too. What time did you go there?
We did it around lunchtime, so
Yeah.
just because a lot of people who are working
Hmm.
here in this area are traveling.
Yeah, but if you go at heavy traffic times, you're probably going to get a more local, like you know,
So that's what we try to do.
in the mornings and around 5, and then at lunch. Yeah, probably be more local.
How there was
Hmm.
other people.
Yeah. What about customer survey at Macy's?
A lot easier.
It was pretty easy. That's what I should have done. Do Macy's customers drive trucks?
Probably
They
not.
probably have one at home.
I was asking though for that one.
Oh, sorry.
No, that's okay. Go ahead.
What was the question?
So do Macy's customers drive trucks? Did you get a lot of trucks in your sample?
Yeah, well, I did it on Sunday, so there's a lot of like families that go in,
Mm-hmm.
you know, and then I work at the mattress department, so this is like the bottom.
Mhm.
A lot of people use it as an entrance to
Mhm.
get in. So like, if I would have done it during the day of the week, I probably would have got like a bunch of cars because no one visits that department very often.
Right.
But since I did it on a Sunday, I got a lot of families going in. So
So you got pretty good truck
yeah, I got more
representation.
trucks than cars.
Oh, you got more trucks than cars.
Yeah.
Oh, wow. Okay, so let's figure it out then. I'm curious, or let's not figure it out. But I want to know what your estimates were. So let's get some guesses. So what did you guys get for your count? So just throw them out there, maybe one at a time. Hopefully, just
80%.
you got 80%. That's what you got? 80%. So 80% trucks. I got a 23%. Okay, so who have I not written down yet?
I got 33.
We got an 8%. Did you say 8%? I got a 33%.
39.
What was that?
39. 49.
Ooh. All right. 20 got 25%. I got another 25%. Can we just scratch that? Yeah, I'm a little curious how you came to the 80%. That would be.
I think I rounded too high.
You got a lot of trucks. So, rounded to the nearest 80%. Yeah. So, okay. What else?
31.
31%. There really is no wrong answer, by the way. So,
I also got 18.
you got an 18%. Okay. What else? Anybody have not written down your number yet? 15.5.
Got 65.
Ooh, you got a 65%. That was the Macy's sample?
Yeah.
You got a lot of people with trucks in Macy's. Okay. What else? So you're like, okay, what else? Any other numbers that we haven't really got yet? 44%. Someone else just said 45? 45%. Anything else? Okay, actually, I got a question though. If this was your number, tell me what your sample size was. So who had 80%? But you had what was your sample size?
I have to go back into my notes.
Just give me approximately how many you looked at.
About 500.
Okay, I think you might want to check your proportion calculation, just because I think, anyways. But 500 is a lot. 150 here.
200.
200. Hey, you guys had good sample sizes.
120.
120. What else? Who had 33%? And how many people did you talk to? Or how many trucks did you count? Or cars? Nobody's going to own up to 33%? It's okay if your sample size was 10. I don't really care. I was just curious. Was your 3? Did you count 3 cars? 1 out of 3? 1 out of 3 was a truck? Okay, nobody's owning up to 33%. Who got...
I have 33.
Oh, how many cars did you sample?
Total there was 308.
308, yeah. What about this one?
42.
42, okay. What else?
Oh, that was 79.
You saw 79 cars?
100.
100 cars? What else? 125? Yeah? Anything else? Yeah, a lot of people hit the hundreds. Did anybody do like more than 500? Yeah, how many did you do? You did 600? Which was your estimate, the 18%? And then who did more? You did more? Which one was yours?
I did 800 and it's 15.5.
You did 800? Hmm.
Where did you go?
I kind of did the same thing as you. I went to G-Way, but I counted them for 10 minutes.
As they drove by.
Each place, yeah, and most of them were around like 300.
Did you just go to G-Way?
No, I went
Oh.
to G-Way, I went to Clearwater, and I went to
George Washington Way?
And then I went to Court Street in Pasco.
Court Street.
And counted them for 10 minutes. And then
Okay.
I went online and took the stacks and then
Yeah.
did it from there. Like counted how many cars per family and how many people in each family. And
Yeah.
did it that way.
Okay. Cool. Any other sample size? Anybody do more than that? Anybody do more than 800? 800 is a lot. It's a pretty big sample. Okay. Cool. So what do you think the real percentage is? There is no real percentage. It doesn't exist. It does. It exists. Okay? Because if we could freeze time right this second, okay, just freeze everything, and then we could go around and count, right? And we could. There is a true percentage right this very second on the roads in the Tri-Cities. It's just we can't actually know it. It's impossible to observe, right? It's a parameter. So, are we comfortable making a guess though at this point? I don't know. The big sample size is, well, this one was 80%. I'm suspect about this. This is another thing we're going to talk about. When you start to see outlying observations, you really want to dig into that data and figure out why you got that outlying observation. It could be calculation error. It could be something about the way you took a sample. I think that one's probably a little bit of an outlier. I would say probably it's safe to say it's somewhere maybe between, 10 and 30%-ish? I don't know. We got a couple above that, though. What do you think? Anybody willing to make a bet on it? Nobody's.
15 to 21.
You'd say 15 to 21%, so you're going to get more specific.
But that's going off the 1% I had. Now I would say 10 to 30 is probably about right.
10 to 30? Yeah. So, but I mean, this is sort of the frustrating thing about statistics, though, is because every single time you go take a sample, what's going to happen? Your percent's going to change, right? And so, what do you think would be a really good idea to do with our data? What's one thing we could do?
Find a mean.
So we could average out our percentages. You'd probably want to weight them, though. Why would you want to weight them? Can you think about why I would want to weight my percentages? Who would I give more weight to?
The lower end probably, or the higher end.
Bigger sample size.
Yeah, I would probably if we're gonna weight them, we'd probably want to weight the bigger sample size a little more. What's another way we could do that though, without averaging proportions? If I wanted to weight bigger sample sizes better.
Do you just like keep repeating it and then you find like an average of all your numbers?
Yeah, so we could redo it a bunch of times. Although I already have like 60 replicates of this study because I have 60 students. So what could I do?
See which one's the most common.
Could see which one's the most common. I was thinking I could just combine all your data, right? I could just take everybody's, because by the time I get 60 people, I'll probably have about, 6,000 observations. It's a pretty awesome sample size.
So what did you use it?
I forgot. Let me see. Let's see. Okay, so I'll show you how I did it. I got a little bit too excited about this. So I, of course, wanted to take a random sample, okay? Because random samples are, it's always good to have randomness. So I'll show you what I did. Let's see here. It doesn't like the R. I need to download it and open it. So what I use is this statistical software called R, and it's it does programming. I think WordPad will see it. Okay, so here's what I did. I went to Google Maps. Okay. And I zoomed out here. So what I did is I looked at the Tri-Cities, and I basically got like I boxed it, sort of, right? So I went to like the most northwest corner of what I consider the Tri-Cities, right? So here's the north end of Richland, and here's the south end of Kennewick-ish, yeah? So I kind of did a southern and a northern boundary on the Tri-Cities, and then I did the same thing for like an east and a west. So I kind of cut it off somewhere here around the edge of West Richland-ish. I was counting West Richland as the Tri-Cities, and sort of an eastern bound to Pasco, right? So I went and I dropped a point, I think somewhere, like around here, And what's here? I don't know. But what it'll do is it'll tell you the GPS coordinates, right? It'll tell you down here, Google will tell you what the GPS coordinates are of that location. So I did basically like a GPS grid, and I got my boundaries of the Tri-Cities. And then I went in, close that, let's see. By doing what I found was a good, maybe. You guys like that panda? It is really cute. It's an adorable panda. Let's just download it because it's taking forever here. I don't know why the panda can't figure it out. So I came up with a boundary. To me, it looked like the, I think this is the north boundaries. So a good north boundary was 46.33 whatever, and a good southern boundary was 46.11. Okay, and then a west boundary and an east boundary on my coordinates. That's what I did. So then what I did is I plugged these coordinates into a random number generator. And so I said north-south, right, and east-west coordinates. So what it does is this code right here, it randomly generates 25 coordinates between my limits on north-south. So that's what I did is I randomly generated 25 numbers. And then I randomly generated 25 coordinates east-west as well. Yeah? So I had 25 north-south coordinates and 25 east-west coordinates. And then this cbind, all it did is I combined them into a column. This is what I did my north-south here and my east-west coordinates here. I combined them into a column. And then I saved them as an Excel document right here. That's what I'm doing here, is I'm writing it as an Excel file. So anyways, once I got that finished with, here we go. This was download. So I pulled them all up into an Excel document. So here was my east-west. Here were all my north-south coordinates that I generated. Here's all my east-west coordinates. So then what I did is I just went in and picked places. So like this one was a popular location. So I would take my GPS coordinates and I would go to Google Maps and I would just drop myself. I'd say, hey, where is that? And say, hey, that's right here. Oh yeah, this one was a big one because I ended up getting dropped right by Ruth Livingston Elementary. And so I would just drop a guy in the nearest road next to that, and I would just like count up all the cars. So I was taking Google Maps, and I would count all the cars, and then I counted how many trucks there were on each location, which was kind of a pain because since it was random, I ended up with some like way out in the middle of nowhere. So I would just drop myself near to the nearest like populated road. But yeah, so I ended up with coordinates pretty much in every city, just with the random generator or whatever. This one ended up being like a lot of cars and like no trucks because it was during the school day at a parking lot or whatever. But anyway, so I did that, and after counting, so you can see some of mine is like there was like 3 cars and no trucks. Some of them had lots of trucks. Like here, I only saw 6 cars and 4 of them were trucks. I don't even remember where that was. Let's see where that was. And sometimes I cheated. So like this one, let's see where it was. Oh no, that was, oh yeah, see that was out here by the New Country Mercantile in West Richland, Richland-ish, whatever you call that place. But if you drop a person there, like that place doesn't even exist on Google Maps yet. And so like I dropped myself down here by the construction or something, and I got a lot of trucks because it was a construction site, right? So that one was like a high percentage of trucks, I think. Anyways, at the end of the day, I ended up counting 190 cars and 34 more trucks. So my estimate was 18%. But what do you think? Too low? What's wrong with my strategy?
That data, the Google Maps is old.
Mm-hmm.
The pictures are like months old.
Yep. So in the case of the one we just looked at, right? This is a neighborhood being built, but that neighborhood's been there for like a year and a half now. Right? Those houses are out there. The Country Mercantile is built. It's been there for a long time. Okay. So some of this stuff is old. So that's one problem. I have outdated data. What else is wrong with that? And yeah, it involved too much thinking. Yeah, I thought about it too hard. I was thinking too much, right? Actually, this is really old. I think actually this construction that they did here was like years and years ago. Some of it's newer. Some of it's pretty old. What else? Any other problems with my strategy? No? I don't know. The other thing to think about is when the Google car runs. So except for like major roads, the Google car tends to run on like during lower traffic times. So they try to run their routes when they won't hit tons of traffic for obvious reasons, right? So that they can get around the streets faster. So you see a lot of the Google car runs around a lot on like Sunday mornings and times like that. So it could be bad. It could be bad in that sense because it could not be representative. If they tend to run early mornings more often, then I could have a bad sample because the trucks might be more likely or less likely on the road in the early morning. So, yeah. Any other complaints in general? Did you guys enjoy the assignment or not enjoy the assignment?
No.
No, you did not enjoy it?
No.
Why not?
Because I have so much other homework and I had to work all weekend.
Oh.
I'm a little salty about it.
You're a little salty about it. That's okay. That's okay. I enjoyed it, but that's easy for me to say, right? Yeah. So what do you think? If you had to do it again, would you do it the same way, or would you change the way you did it?
I'd change it a little bit, but I wouldn't change it very much.
Yeah, I think I would do it differently. I just didn't want to go anywhere, so I was being really
I
lazy.
didn't want to go anywhere either, but I just
So.
tried using Google Maps.
Yeah.
I would use your way.
So maps, okay. I don't know. I think I would still use maps to generate the coordinates, but I think I would actually physically go to those locations instead, though.
That's a lot of driving.
Yeah, it would be a lot, but I would probably try to hit the locations. But I probably wouldn't select 25 locations if I was going to do it that way. I'd probably randomly select maybe like 5 or 10 if I had to do it again. But actually, what I'd probably do is I'd try to query DOT records or something. That's what I'd really try to do.
It's not online.
Yeah, probably not.
Yeah, I tried that.
Yeah. If you had a source.
Yeah.
So, anyways. Okay, cool. So, I got another one coming, but I'll give it to you tomorrow. Okay? So, it'll be just as fun, if not more. Okay. Any questions before we go? I want to finish out. We got just enough time. And chapter 2 is way easy, so I just want to. We can knock that out in no time. But I don't want to move on if you guys have anything you wanted to ask. No? Feel pretty good about that? All right, so I'll take a look at your stuff. If you emailed them to me, that's fine. I should have emailed you back saying I got it, unless it was sometime since 9 and now. But I uploaded most of them today between 8 and 9.
So are we supposed to turn in like what we actually did or just the answers to the question?
I didn't really specify that much. But in the future, yeah, I mean, I'll take as much as you want to provide. So if you want to submit your data or you want to submit your work or whatever, you can do that. And I'm happy to take it by paper too. You don't have to submit it electronically. That was mostly for my online class. So for you guys, you're welcome to print it out and bring it in. So, any other questions? No? All right, cool. So I'm pretty happy. You guys did a lot of work, actually. I'm actually pretty impressed. Not that I doubted you. Okay. I was expecting great things, and you all delivered. Okay. That was wonderful. Okay. All right. So one thing we're going to do, though, before I go, sorry, I'm getting distracted, but we're going to talk about this idea because the problem is there's variation in your sampling, and so what we're going to try to get to eventually is that, realizing that when you take a sample, your estimate is actually probably wrong, right? It's probably off by a little bit or a lot, and so we want to try to find ways to quantify that uncertainty. It's like, how certain am I that it's really 18%? Could it be as high as 25%? Could it be as low as 10% or something like that? Okay. So, but we'll get to that later. All right. So now what we want to do is we say, okay, we know how to collect data, and we've done that now. So now the question is, what do you do with it once you have it? And typically speaking, the first thing you want to do is you want to make some graphical summary, like graphs about it. Just as a review, though, we have the difference between types of data. So you have qualitative and quantitative. Qualitative we also call categorical. This was from my slides last year. Okay. So if I'm looking at a data set here, say these are entrants in the Boston Marathon, what types of variables in this data set are categorical? Okay, so gender is a categorical variable. What else? Yeah, so their entrant number, okay, is really categorical probably. It doesn't really probably mean anything except for it maybe judges what time they signed up for the marathon, who signed up first. You could call it quantitative too, but anyways, what are the quantitative ones then, and which ones are discrete and continuous? At least the way they recorded it.
Continuous would probably be finishing time.
Yeah, so the time it took them, that's definitely continuous. You could treat age as continuous if you wanted. At least the way they recorded it discretely. But I would say, technically, yeah, I mean, you could put age there. Typically, we round off to nearest year. So either way. And then what else? Yeah, place is definitely a discrete variable, right? Because you can only finish first or second or third. All right? Okay, so you have your data, and you're going to record either qualitative or quantitative data. In our case, actually, did you record a categorical variable or a quantitative variable when you were taking data? You were actually recording categorical. Why? Yeah, it was truck or not, right? So you were just looking at a categorical variable. Even though at the end of the day we ended up making a number out of it, the actual raw data was categorical, right? Okay, so depending on what type of data, that's going to drive what types of graphs we're going to create. So graphical summaries, these are basically pictures. So what kind of graphs have you seen data summarized in before? What kind of ones are common? Yeah, so pie charts, pretty common. They're pretty and colorful.
The plot and dot with the line.
Yeah, so you can see something called a scatter plot or sometimes a line graph. Sometimes they're together. Okay. Scatter plots are when you're comparing two variables. We're going to talk about that in Chapter 4. Line graphs are when you're measuring data over time. We're not going to do a lot of line graphs, but we will do some scatter plots. Any other types of graphs you've seen or you're familiar with? Yeah, like bar charts. And then there's also something called a histogram. And we're going to talk about those a little bit. So those are probably the main ones that you see data picked up into. And actually, it turns out it depends on what type of variable you're measuring drives which one of these is appropriate. So beyond graphs, okay, typically people want more than just pictures. So then we have numerical summaries. And a numerical summary are they're single values which attempt to summarize some aspect of your data. What are some numerical values that we actually use one in our data set? We ended up with a numerical summary. What was it? Yeah, percentage. So percentages or proportions, right? So you ended up taking a whole lot of data, right? But at the end of the day, you only reported a single value, right? That's a numerical summary. What else? What other types of numbers have you seen that summarize data? Can you think of another number that would summarize data? So I have a whole bunch of numbers. How could I summarize them? So say that I measured everybody in here, and I measured how many credits you were taking, right? So for every single student, I have the number of credits you're enrolled in. What could I do with all those numbers to summarize it into one number? Yeah. You could use StatCrunch, and StatCrunch you would produce maybe something like an average or a mean, right? Are there other values you can think of that summarize data that you've heard of? Yeah, there's a lot of other ones that go along with that, like the median. We're going to talk about mean versus median and why you'd use one over the other. Something else we're going to see in here is something called the standard deviation. That's something we're going to talk about. It helps measure how spread out your data is. So one aspect of your data is kind of like where's the middle of it. That would be like your average. But another aspect is how variable is your data. You know, do we have students everywhere from 5 to 20 credits, or is everyone mostly centered right around like 12 to 18? Okay, is your data really spread out or not? But it's just a single value But we're going to save that. So this is actually going to come in. We're going to get back to this stuff in Chapter 3. Chapter 2, we're just going to knock out real quick, talk a little bit about graphs. All right. So the idea is, depending on what type of data you have, that's going to drive what type of graph you make. So, for example, and again, this is from my last book, so I'm going to change that to categorical. But they're synonymous, qualitative, categorical. So categorical data, the thing is that you're just observing things about people. So you really can't average categorical data, right? I can't average people's eye color, right? And come up with some weird average. Okay, it wouldn't make sense. And so we're really mostly stuck with proportions or percentages. So for categorical data, the things that work really nice for it are bar charts are really nice, and pie charts work pretty good. Yeah. So you can show like what chunk of your population has this aspect. You know, it makes a nice pie. Whereas for quantitative data, that's where we want to use most often is, and what we're going to use most in this course is going to be histogram. But you could use a line graph. That's for data over time. And you could use a scatter plot. And that's for comparing two variables. Right, if I want to compare the number of credits you're taking versus the number of hours you work or something, right? If I want to look at those two variables, how they interact with each other, I might make a scatter plot. We're going to talk about those. These will come in Chapter 4. Okay, so we're mostly going to stick, for this course, we're mostly going to stick with, or for Chapter 2, we're mostly going to stick with these three. All right?
What's the top one for? Just anything?
Histogram?
Yeah.
For quantitative data.
Well, like,
So.
you said this is for time, that one's for
So it's the histograms for basically everything else.
everything.
So all the quantitative, if it's not measured over time and then you're not looking at two different variables, then you're probably going to stick with a histogram. So it's just when you record a numerical value about a whole lot of people. Okay. So like if I recorded everybody's how many hours you work per week or something, right? And so I got a whole bunch of hours for everybody, then I'm probably going to put it in a histogram. Okay, so you're probably pretty familiar with most of these. They typically start as tables, so we call those frequency distributions. And in a frequency distribution is you break down things into the category and the number of people who fall in that category. Okay, so in a frequency distribution, you're just recording how many people were there. So in this particular example, you have people identifying as Democrats, Republicans, and other, right? So in a frequency, you just list off. So there was 13 Democrats, there was 18 Republicans, and there was 9 identifying as other. And then so as a total, right, I think we had 40 students, something like that. Okay. Frequency distribution, pretty easy. Yeah? Not too bad. So it's basically just a table. And again, all of these qualitatives should say categorical, so sorry. That's what I get for copy pasting things. But oops. All right. Sometimes the counts aren't that informative. Like if I say, oh hey, I took a sample and in my sample 13 students identified as Democrats. What information are you missing from that statement? What did I not give you enough information on? Yeah, I didn't really tell you how many I sampled, because if I sampled 14 students and 13 of them were Democrats, that's a lot different than if I sampled 100 students and 13 of them are Democrats, right? So one way we do that without having to report the actual sample size is, rather than do frequency, we just do relative frequency, okay? And the relative frequency, right, it's just the number out of the sample size. So we're going to basically send a proportion or a percentage rather than the actual counts. So it looks just like the frequency distribution. So we still have Democrats, Republicans, other. But now rather than giving you the counts, I'm going to give you the proportion. So 13 out of 40. So who's got a calculator out? Anybody got a calculator on them? What is that? I can do it too. 13 out of 40? Yeah? What is that, 0.325?
Yeah.
Right, so I would report that and say, instead of telling you that 13 were Democrats, I tell you that 32.5% of my sample was Democrats. That's a little more informative, right? Here, this would be 18 out of 40.
0.45.
0.45. Okay, and then this one would be 9 out of 40. So that would be, these aren't even approximate, actually. They're not rounded. What is it? 0. Point.
Oh no, it's 4 point. Hold on.
Anybody got it?
0.225.
0.225? Yeah. Okay. So you would just report the proportions. And notice, what do these add up to? Yeah. They ought to, right? So your proportions better add up to 100%. If they don't, that means you made a mistake or something weird happened. Okay. So your proportions should always add up to 100%. And we're going to typically deal with proportions or percentages as proportions, like in their decimal format, right? Because that's the way they're easiest to do calculations with. That's what we're most comfortable with in math, is with the decimals. All right? Cool. So far, so good? Easy peasy. So once you have those charts, well, people don't like charts because, I don't know, they're boring and you can't make them colorful or something. So typically what we do is we take, say, like a relative frequency distribution and we turn it into a pie chart, right? So if you go back to that relative frequency distribution where you had Democrats, Republicans, other, and it was something like, what was it, 325, 0.45, 0.225, something like that, right? So then you're just going to transfer that into a nice big pie where you give each category that percentage of the pie, right? And how many degrees are in a circle, right? So for Democrats, they're going to get, the Democrats are going to get 35% of the 360 degrees. So they're going to get whatever, right? Yeah? What is that? Anybody got their calculator? What is 32.5% of 360 degrees? $117?
Yeah.
Anybody else got 117? So they get 117 degrees of the pie, right? So then it's like, that's basically a third, right? So then the Democrats, they get this chunk. And then a lot of times you'll see the proportion written in there with it. Then Republicans, they got 45%. That's almost half. Yeah, so they get a little less than half of the circle. And then the others get the thing in there, right? And then a lot of times they give them nice, pretty colors and stuff, right? Because that's pretty fun, I guess, if you like colors. I think I can do colors on here, but you probably can't even see them up there. Because you don't even see like the red on the display very well, do you? Oh, you can see that it's red?
Yeah.
Oh, you can? Oh, nice. So we could give like this, unless you're colorblind, sorry. If you're colorblind, you're not going to be able to see the difference between those two colors that well. Anybody here colorblind that wants to admit it? Red and green is tough to distinguish for some colorblind people, which is really ironic because that's what colors are like stop and go on our red lights. But I guess red's usually on top. That's the idea. So, yeah. Between red and green? Yeah, I actually had a classmate when I was in grad school. He was colorblind to red and green, and this guy came in, and we used to have colloquiums where professors from other universities would come and give presentations. He gave this awesome presentation, but the difference between the data points were red and green. So they were like showing how you have different trends. So like together it looks like a mess, but then if you separate it out, you can see like the green dots had a pattern or whatever, except for he couldn't see anything. To him, they all just looked the exact same color. I was like, wow, those are really unfortunate. So in general, if you're ever preparing graphical displays, don't use red and green, right? Just use something else like patterns or something or whatever. So anyways, So everybody feel like they can make a pie chart? I think you can all make a pie chart. Bar charts are pretty much the exact same information, but instead they're going to do, that's just turning that frequency distribution into a nice graph. So whereas we had our actual counts, it was Democrats 13, Republicans 18, other 9. So now you just draw nice little bars that height, right? So what's it? 5, 10, 15, 20. Not very good scale, but anyways, what Democrats go up to 13. Republicans go up to 18-ish, and others down here at 9. Right? Sometimes you'll see the numbers written on the bars. You don't have to. But right, so it just gives a really bar charts are nice because it really quickly identifies, the difference between two groups. It's also a better way to distinguish between groups that are close, right? So in a pie chart, sometimes it's hard to distinguish which slices are bigger than others, especially if they're similar size. But on a bar chart, it's really easy to look across, and you can see which bars are higher than others, right? So that's the main advantage. But it doesn't give you as good an idea of the overall chunk, like proportion-wise. And notice in a bar chart, the bars don't touch. That's significant because for categorical data, we could relist this in any order, right? There's no reason I had to put Democrats or Republicans or other first. You can move them around in any order you want. Okay, so the bars don't touch, which will be different than the histogram. Okay, so the problem happens is the problem you run into is that when you start getting continuous data, or qualitative data, you have this continuum of values that it can take on. And so here we're looking at the number of TVs per household in a sample of 50 homes. Well, I need a way to break this apart to make more sense out of it. So typically what we do is we use bins. Sometimes we'll use single value grouping. So like here's discrete. So our numbers only go from what? They only go from like 0, up to 6, right? So if you don't have that many potential values, then you can just treat it like a categorical variable, right? Where you just make counts, right? So number of TVs and the frequency, and then you just go and you count them up. So how many people had no TVs? Just one person. Okay. How many households have one TV? You count them up and I'll see if I agree with you. What do you think? I got 16 too. Okay. So 16 had one TV. What about 2 TVs? $14? People agree on 14? Okay, 14. All right, let's do 2 at a time. So your half count 3s, this half count 4s. Tell me how many 3s there are and how many 4s there are. And we'll see if we agree. I got 11 3s. 12 3s. I like 12 then. What about 4s? 3 4s? 3 4s? 12 3s and 3 4s. Okay. Now, this half, you guys do 5s and y'all do 6s. Two 6s? How about 5s? 2 5s, 2 6s? Okay, is there an easy way to check if we made a mistake? Yeah, probably a good way would be to total these up and make sure that we come up to 50, which 30, 42, 45, yeah, looks good. Looks like 50 to me. Yeah. Right? Okay. You can add them up, it is. So, all right, so the problem with that strategy is when you don't have discrete variables, or if you have a lot of values that are possible for your discrete variables.
It's an organizational. I guess if the histogram was like organized by number, it's confusing to look at.
What, this right here?
Not that.
Oh, that?
That.
Yeah, well, that's why we don't just use raw data. It's because raw data is really annoying to just look at, because that's obnoxious to me. It's hard for me to pick out any patterns.
The histogram
So this is just a frequency distribution. We're going to turn it into a histogram in a second. But yeah, so that's what we're trying to do. We're trying to take all those massive amount of numbers, and we're trying to condense it into a way that makes it easy to understand. Right? That's the goal. But you can't always use this like single value grouping strategy because here we're looking at the dates of maturity to investments. What's going to happen if I try to make a category for every single possible number of dates? Yeah, my chart is going to get huge, right? Because all of these things have different dates. Maybe one or two of them share, right? But almost everything has a unique entry, right? So that's a problem. So what we normally do is we use what we call limit grouping, or sometimes I call them bins, okay, or classes. Sometimes you'll hear them called classes. And so what you need to do is you need to look at the spectrum that your data covers it, and then you want to cut it into groups, like equal size groups. So what's the minimum and maximum number of days here?
99.
You see a 10?
Bottom right.
10, and what's the biggest one?
99.
99. So our range here is like 10 to 99. And so typically you want to split it up so there's about like 5 to 10 groups is what you typically shoot for. So one thing we could do is we could say we're going to split this up, say maybe 10 to 19, 20 to 21 or 29, right? And so you start grouping them together. So what would that be? 40 to 49, 50 to 59. All the way up to, this would be one way. We could have grouped it by 20s as well, right? And this is frequency, right? And so then what you have to do is you go in and you count up all the ones that fall in that category. Right. We're out of time, actually, so we're going to have to finish this off, tomorrow. I think if you go into the Chapter 2 homework, though, I promise you it's really not that bad creating these graphs. Most of them are pretty intuitive, but we will still finish these off tomorrow, okay?